Hello, everyone.
Hello.
Thank you. We're very excited to be here presenting CosMiss FabriXss and more, how we managed to find various vulnerabilities in Azure flagship services. Firstly, let's say thank you for the team, Ila, for helping us, so everyone around, and yourself. We hope you enjoy it. So, yeah. Let's start introducing ourselves. So I go by the name of Lidor, working at Orca for almost 2 years now. Mainly focusing on finding vulnerabilities in cloud services, right? So mainly Azure, as Dave Chappelle just said. AWS, GCP, etc. You can find my finding and vulnerabilities in research in our blog, obviously, in Orca. This is Caesar, is my Twitter, although I'm not that active on Twitter, to be honest. A little bit about myself. So I'm happily married to Adi, which sits in front of you. I said happily because she sits in front of it, but that's about it. Roee?
Hello, everyone. My name is Roee, working at Orca Security for the past 2.5 years now as a security researcher. My main focus is Azure research, finding new vulnerabilities, and writing new detection techniques to our product. A bit on my background, at my previous role at the IDF, I spent approximately 5 years researching operating systems. So let's begin.
Sure.
So what is cloud? So when talking about cloud computing, just kidding. You know it. And OK, so at Orca Security, we provide our customers deeper understanding of their cloud environments and helping them implementing security best practices. Our goal is to minimize the risk for cyber attacks and data breaches. During our work at Orca, we've came across several vulnerable Azure services, vulnerable to a variety of vulnerabilities, such as XSS, SSRF, push escalation, and, as we'll demonstrate later on the presentation, remote code execution. Among those services are Azure Service Fabric and Azure Cosmos Database.
Yes, so we decided to mainly focusing on Service Fabric and Azure, as we mentioned in our title, because they are flagship services, right? And they have a deeply integrated within the Azure ecosystem, meaning that, like, let's say finding vulnerability within those services can yield, let's say, very interesting findings or implication on and consequences for millions of Azure users. So that's like the main goal of searching those vulnerabilities in these two services. Obviously, both of them are being integrated within each other, but we not covered it in this specific talk. But generally speaking, we deal with many services. These are the main ones we will demonstrate in this presentation. So in terms of like the concept for this talk, so we hope you enjoyed it, first and foremost. Second of all, we aiming to provide, let's say, a walkthrough, like step by step on how we managed to find these vulnerabilities. And like we provide the do's and don'ts, and we discuss the mindset and how we came up with finding those. And yeah, so cool. So let's start. So firstly, we'll speak about FabriXss, and later on we will demonstrate on CosMiss. So let's start by what is Service Fabric. So Service Fabric, in general, you can think of it as like a cloud-based platform that help you manage and let's say, build your microservices application. So you can think of it as the buzzwords Kubernetes, but it's not Kubernetes. It's like the version for Azure to set Kubernetes, right? You can think of it similarly. On the other hand, you have the sexy dashboard on the right. So this is Service Fabric Explorer, and this is where both of our vulnerabilities relies on. So Service Fabric Explorer is like the dashboard, as I just mentioned. You can see here like the nodes, the cluster, which demonstrates the health of the cluster. You can see the system namespaces, also the containers themselves. Generally speaking, like, let's say, a generic dashboard that helps you build your cluster, right?
OK, so it might help them think about it as a Kubernetes with a dashboard, right?
Yeah, exactly. So think of it during this presentation for both FabriXss and the later one as, let's say you find vulnerabilities that we just going to demonstrate. Let's think about it. What's the implication in terms of cluster / Kubernetes / Docker, etc. So cool. So once you set up Service Fabric So once you set up Service Fabric in the portal itself in Azure, you've been given the external dashboard, which is Service Fabric, right? So once we enter the Service Fabric Explorer, we immediately start to poke in on it and start to searching for different capabilities, right? So different abilities or something that will, let's say, like an eye candy that we could leverage and finding vulnerabilities in. But we came up with nothing, basically. A few good moments after we found out this specific menu on the right. So you can see we are able to switch to the view old SFX. SFX stands for Service Fabric Explorer. So it gives the guys at Azure provides the ability to switch to the old SFX, and this is where our story began. So once I switched to the SFX, to the old one, I immediately noticed two main things, right? Two main different capabilities that were not enabled by default in the new one, right? The first one is like basically very important, is the create new compose deployment. We will get there in a minute, but just think about it, that you were able to create a container using the UI, something that is not enabled by default in the new one. It only enabled via the SDK or CLI, but in the old one, you can manage to do so by clicking on a few buttons and then able to create a compose deployment. Another thing that I want to highlight here is once I noticed that behind the scene in my Burp suite, I noticed the following requests that were sent. So this is, you can see behind me, the AngularJS 1.5 version. So immediately, I'm assuming you guys, some of you are bug bounty hunters, etc. So once I immediately noticed that it's an AngularJS framework, which is a JavaScript framework, I immediately thought about CSTI, which stands for Client-Side Template Injection, right? Or other various vulnerabilities, such as SSTI, which stands for Server-Side, right? So this specific version is kind of old, right? So I immediately thought, what if the specific dashboard is vulnerable to CSTI, right? So remember previously I just mentioned the create compose deployment application. This is the button on the left side. So once you create a container, I provided with the following name. You see double brackets 7 times 7. You can ignore the CSTI for a minute, but the payload itself is 7 times 7 with the double curly brackets. Once this was rendered and created, you see the 49, which stands for, like, obviously 7 times 7, but it was a great indication that indeed this may be vulnerable to CSTI. The next move will be to try to verify it by providing the upper left payload, which is somewhat similar to escaping an AngularJS framework, but in order to pop the famous alert box on the right. So we found the specific payload, HTML encoded, then provided in the name parameter, and then slowly after it was obviously being verified as vulnerable to CSTI, right? Which is very, very cool.
Wait, don't get me wrong. It's very cool, very good vulnerability, but you just said this is a client-side vulnerability, so why do you even care? Why?
So they should care, because if this was vulnerable to CSTI as client-side, it's not that dangerous at the time, right? But I thought that if it was indeed also verified as vulnerable to other vulnerabilities, such as, you guessed it, XSS, so this makes the story much more interesting and dangerous. And we can try to demonstrate it by trying to verify it's being vulnerable to XSS by the next slide. So once we created an application and provided with the following payload you see on the left, we name it with a hashtag in the beginning and the closing span time, etc., but it's not really important at the moment. You need to remember that we have faced many restrictions in terms of like the naming for the container. It couldn't contain any script tags or any blank spaces or other things, but generally speaking, we found out that this could work. So we provided, created the container, and soon, you know, the style tag was being created properly. So again, a great indication of this could be injected to something more dangerous. Now, I want to say a small disclaimer here. Not disclaimer, but parentheses, they call it. When I work essentially on Azure portal, I managed to find many HTML injection, right? But the thing is that the guys at Azure do like a great job sanitizing user input. So you can find HTML injection, but you cannot leverage it into an XSS. So fortunately, because we're standing right here, this was not the case. So providing the following payload, again, without any blank spaces, you can see the slash and start with the hash sign, HTML encoded, and vulnerable to an XSS. This is a stored XSS, right? Now, one thing I want to mention about Service Fabric Explorer is that this is a shared dashboard, right? You can see, like, once you create a container, as any type of user, whether you are admin or, let's say, a hybrid one, as we will discuss shortly after, any user be exposed to the same application, meaning that if I, let's say, just created an Nginx or IIS container, any user can use it and see it as well, right? So we came up with, like, just immediately thinking how we can demonstrate to the team at MSRC that we work very closely with, how we can demonstrate proper vulnerability and how we can demonstrate it as a POC for them to deal with. Yeah, we set up a lot of good memes. So before jumping into the specific payload and the POC that we managed to build, let's briefly discuss, like, the Fabric custom settings. So importantly to know that once you set up a service fabric, you've been given the ability to create two main users, right? So you have the admin, which is the one who controls the cluster. You can create compose deployment. You can do pretty much everything. And you have also a read-only user, which is not able to do anything, right? You can only view the metrics, and you can see, like, the application that were created. So this was a quite challenge, right? You want to add something to it?
Yeah, so exactly. This is default settings, but think of the following case. You might have an external user that you want to give access to. And this external user might need to, I don't know, create compose deployment, for example. So for this case, you can edit the client access permissions and replace the read-only permissions with any permission that you want. So for this case, for this scenario, we switch the read-only access with create compose deployment.
Yeah, so thank you for clarifying it. So on the lower side, on the lower part, sorry, you can see, like, screenshot that was taken from Service Fabric repo, which, if you guys noticed, it has a restart in the end, and you have nodes at the beginning, and the encoded URL component, it's like the node name. So this REST API endpoints aim to reset the node, generally speaking, but, like, we thought about what if we managed to abuse, like, the admin permission in order to create a POC to demonstrate how we can abuse the administrator permission without even knowing, or trigger a REST API endpoint on its behalf. So shortly after, we came up with the following workflow, right? So you have a low prev user on the left, which is creating a compose deployment, entering a crafted XSS payload in the parameter, right, in the name. And once it's been created, now it's set up for basically forever, right? Every user that will encounter the same container will now be exposed to the stored XSS. The admin on the lower left is like the admin. Now, once he will face the same container app, the malicious one, an iframe that we used in the XSS payload will be embedded, grabbing a fetch HTML file from the ngok server that we control as a remote attacker, and execute and trigger the restart NPI 8 point, right? So shortly after, we built a very sexy exploit using a very nice ASCII art, right? We love ASCII art.
We love ASCII art.
Yeah, we think that every great exploit comes with a great ASCII art, so this one is aimed for a low prev user to abuse. He just needs to provide a payload using the payload argument you see on the left, and that's about it. So sending the payload and trigger it will cause the following. So we have an iframe that was being embedded. By the way, this could obviously being created behind the scene by providing, like, a size parameter, right? But we want to demonstrate it with a full iframe. So an iframe was being embedded. On the left side is, I guess it's kind of small. You don't see it, but you have two requests, right? So you have the first one sending the fetch request, aiming to grab from the ngok file, from the ngok server. The second one, the lower one, is the restart one that was being triggered on the admin on its behalf, so to speak. So once you have this whole type of snowball rolling, you have the node that was being resetted, and you see seed node down, meaning that it caused, like, many interruption with the user experience. You have resetting the settings variables, etc. Like, not some typical reset node that anyone does on a daily basis, which is not typical. So we were able to provide the full POC that we just demonstrated to the team at MSRC. They were assigned with this nice CVE, and we all went happy. I guess it was like a typical day at Orca, but this was very cool. We came back, and that was about it, right? But fast forward a few months ago, let's say about 5 or so, my brain telling me that my story with Service Fabric is not done, meaning that this POC that we just created is a somewhat, I don't know, let's say 90% privilege escalation as we discussed with the team, and we want to provide a much dangerous one, presenting super fabrics, right? So you have fabrics, super fabrics, so this baby on the left is far more dangerous than the first one I just described, right? So super fabrics, as its name applied, and also for the fabrics itself, is an XSS vulnerability, again, with Azure Service Fabric Explorer, only this time, it is much, much dangerous, and we will discuss about now. So once I came back to the Service Fabric Explorer at C, and I just poke around and see what was changed after they patched it, I noticed that in the same menu I previously discussed, you see here that the switch to the old SFX is now missing, meaning that it has no more the old UI, hence you cannot create composed deployment, and we need to find another vector. After a few good minutes or days or hours, to be honest, I'm not remembering, but a few good hours after, we came up with the node profile page, right? So this is a typical node page that Service Fabric has. It has a very common behavior where the endpoint on the URL basically have its name, and the name is being reflected in the dashboard itself. So we thought about the next scenario. We provided with an HTML tags in order to try to escape. Once again, this is very similar to the first fabric. Provide it, and what do you know? Nothing happened, right? So this was a bit, I don't know, bit confused because we did notice it being reflected accordingly with a proper tag, but nothing was being sanitized or nothing was being encoded, as we noticed often that happens in Azure. But then we noticed something else, right? We noticed that under the Events tab, it has the ability to switch to the cluster type toggle, which is like the toggle you see in the middle of the screenshot. Once we click on it, we notice that the same H1 tag you see on the left was being rendered properly in the cluster name. So this one, I mean, we thought about it on how this specific behavior can cause a very serious damage, right? Next move will be provided with a proper XSS payload. Only this time, we aim to, hopefully, will trigger the prompt. Now, as I mentioned previously, I'm not sure if you remember, HTML injection do happen in Azure. We noticed it quite often, but not able to execute an XSS. I mean, the tags are being sanitized and everything is pretty messed up, but only this time we crossed our fingers and hope this will the same happen. So Events tab, selecting cluster type, and the very sexy prompt just being opened will now become a very serious scenario, because only this time, since this is not a stored XSS, I mean, it's kind of hybrid. It's a reflected that became stored, never mind, but generally speaking, this is an XSS that could be triggered from the URL, right? Meaning that any unauthenticated user can send a crafted malicious payload or URL and send it to the admin, right? So you don't need any authentication whatsoever. So before jumping into what we managed to accomplish, I won't say that we faced many restrictions. I mean, the following page that you see right now with, I will talk about it in a minute, but we came like in a many restriction. We were not able to find any way to trigger an RCE whatsoever. And this, I can verify it and say that after a few good minutes of reading the very confusing documentation from Azure, we finally find the following endpoint, which was one that aimed to upgrade the current composed deployment. Now, let me just briefly explain. So let's say, again, you have an IIS container, right? And you want to override it, with another container or Docker file. So you can simply send the specific endpoint with the proper body. You see on the upper left, you have the parameter in the body, and then it contains like very mysterious properties that contains what we know later on, endpoint from the new Docker file, right? So after a few good minutes of tries and error, we came up and find how we can how we can successfully send the payload and the REST API endpoint as it used to be, and we came up with the following workflow. So a remote attacker, which have a hoodie, of course, is sending a crafted URL to any authenticated user whatsoever. It could be the admin, it could be any type of them. Once he will manipulate the same user to trigger the whole scenario by selecting the cluster type, again, this whole snowball starts to roll, and you have an iframe being embedded, fetching a file from the Ngrok server, fetch HTML. Only this time, it will contain an upgrade endpoint, holding what we now know as like the holy grail of the Docker compose file. And later on, Fabric will demonstrate it by taking the specific malicious crafted Docker file that I just created as a malicious user and build it. And once he will build it, he will use, I'm sure you guys are familiar with CMD instruction inside the Docker file. So we use a CMD instruction after it was built. This will trigger PowerShell execute another bat file. Then we'll trigger it once again and gain a remote attacker reverse shell. But why talk if you can see it in action? So let's see. So this will be very quick, but bear with me. So you have REST API endpoint. Currently, I'm highlighting and building the malicious Docker file. You see on the upper left. Yeah, I'm highlighting the image. This is the CMD instruction. Going back to I'm setting up my tree listeners. So you have Python, Ngrok, and Ncat, right? Before that, I'm just filtering up upgrade. Triggering the iframe upgrade REST API endpoint just been sent 202. That was very promising. Upper left, 2 file. Backup and ref.txt that were just currently being grabbed, and boom, we have a reverse shell on the container. Thank you. Yeah, let's just talk about CosMiss. Thank you, guys.
Thank you, Lidor. So now let me tell you the story of CosMiss. So CosMiss is a severe vulnerability we found in Azure Cosmos database, as you might figure out from the name. So let's begin by talking about what is Azure Cosmos database. So Cosmos DB is fully managed non-SQL database with high performance and scalability. And you should know before we begin that it is widely popular. It's widely adopted among Azure users.
I guess that our audience just asking themselves, so why so, let's say, what's so special about Mongo, right? Because it seems like a generic database among other databases that Azure has, but you want to explain?
Yes, of course. So this is a great point because it is database, so it might contain sensitive data, and it is very popular, so if we'll find a vulnerability, the impact will be bigger. But the main reason that we chose Cosmos DB as a target, it is because it's fully managed. And by saying fully managed on the cloud, we mean that every service resource is running on Azure shared environment. And this mystery environment is shared between different customers. So once we'll be able to find a severe vulnerability in this mysterious environment, we might be able to jump between customers and break the basic and fundamental principle of the cloud, which is tenant isolation. And this type of vulnerability is called cross-tenant vulnerability. So we started playing with the service, poking with it a little bit, and pretty quick we found a feature called Jupyter Notebooks. And this feature is an integration between Cosmos DB to Jupyter Notebooks that we all know. And the purpose of this integration is to provide the customer data cleaning and data exploration capabilities, but we looked at it from another perspective. We looked at it as an opportunity to gain some insight about this mysterious environment that I just described. So let's see. We divided the research process for 2. First of all, taking a look, deep dive in the internal infrastructure that I just talked about, and The second vector was to poke with the API to find out which are the relevant endpoints, maybe intercept some requests with burp, and to see if we can find interesting findings in there also. So without wasting any time, we created Cosmos DB account named Orca Cosmos Dev. And actually, you can see here the notebook that I created, and only one cell was needed because we immediately triggered a reverse shell back to our Kali machine. And of course, the Kali address is redacted because we were very, very lazy and we don't want to create another one later. And of course, that we did the whole recon process. We searched for suspicious processes, for unusual open ports, for sensitive file, et cetera, all you can think of. But I think, and you might agree with me, that the beauty in CosMiss is that all you need to know in the internal infrastructure, in the internal infrastructure side, can be presented in just one slide, in this slide. So in the left side, you can see the reverse shell trigger, and in the right side, you can see that the notebook is running in the context of a user called Cosmos user, and in its home directory, we can find two different folders. The first one is work, and the second one is called notebooks. And of course, the notebooks directory is containing the notebooks themselves. You can see the untitled.ipynb, which is our notebook. So actually, this is all you need to know from the internal infrastructure side. Now, let's take a look about the API angle. So once created the DB account, a dedicated endpoint was created, of course. And you can see it here, Orca Cosmos Dev, the documents Azure.com. But when we created the new notebook, another endpoint was created, unrecognized to us at the time, called CSTI.tools Cosmos Azure.com in a randomly generated port between 10,000 to 10,009. And you can see here some sort of API / container gateway / a field called forwarding ID, which is a UUID4 based string. And you can see that we also got an authorization token. And let's talk a bit about this authorization token. It might not seem that odd to you, but usually on Azure, we use bearer tokens. So bearer token is much shorter. It starts with the word bearer, of course. So we immediately realized that there is some sort of integration here, some sort of authorization to a third party. So we thought to ourselves, how can we maybe leak some data, get an interesting error? And we decided to omit the header to see what happens. Maybe we'll get unusual error. And to our surprise, we omitted the header, as you can see, and everything continued to work. And we were in shock, because I just told you how sensitive the service, it might contain a lot of data, and it's very popular, and those notebooks that we're talking about are directly integrated into this service. And now I'm telling you that we can read and write to everybody's notebooks. So yes, this is exactly what we're telling you. We could read and write to everybody's notebooks by just omitting the authorization token. So of course, that we can only speculate why it happened, but taking a look on this GitHub repo, the Jupyter server GitHub repo, we can notice that by default, the authorization token is not being validated. So what we guess that happened is that Microsoft completed the integration and it went very well, everything worked, but this flag remained off. And actually, it will make a lot of sense when we'll talk about the patch later. So we have in our hands read-write gadget to everybody's notebooks without any authorization. So let's see it in action. Here you can see in the burp screen our put request. And I would mark the authorization token as well, but it doesn't exist. We don't need it. And you can see that we're injecting our contents to untitled.ipynb notebook. And we got 200 OK response. It worked. No authorization needed. We can do it to every customer on Azure. And actually, I can't talk enough about how the implications are crazy. But at that moment, we faced a dilemma. We could go out and celebrate, and we did. We did, and it was great. But also, we thought, how can we take our knowledge, the knowledge that we already talked about, the internal infrastructure knowledge, and I didn't explain it for nothing, and upgrade the read-write gadget that we just obtained to remote code execution exploit. So when facing this type of problem, you usually are looking for a sensitive file that is being automatically triggered. And when you'll be able to override this file with your malicious payload, all you have to do is just sit down and wait for the file to be triggered. So this is exactly what we did. And you can see here that in the path content/notebook is matching to the notebooks directory in the container that we talked about earlier. So we try to traverse back and to override another file.
I guess that our audience just asking themselves, but if you manage to overwrite any files, right, within the path traversal, why did we even overwrite any SSH keys or etc passwd?
OK, so this is a great point, because if we could do it, we wouldn't presenting here this complicated path. So we tried, of course, to overwrite some SSH keys, but we couldn't. We came across some kind of path validation algorithm. So what we did find out is that we could traverse all the way back to the CosMiss user home directory. And inside this home directory, we found a folder called .local. And the Jupyter client was stored in there. And we looked a bit, and we found a wonderful file. And the reason that I call it so wonderful, kernel-specs.py, is that because every time you create a new notebook, kernel-specs.py file is triggered. So if we're able to fetch kernel-specs.py file and overwrite it with our malicious payload, for example, trigger a reverse shell, all we need to do now is just sit and wait to the poor Azure user to log in and create a new notebook. And this is what we did. So let's just review the complete workflow. So from nothing, from just giving a forwarding ID, we now enumerate the ports between 10,000 to 10,009 on the CSTI endpoint. And once we found the relevant port, we're fetching and then overriding kernel-specs.py file with our malicious reverse shell trigger. And in its turn, the API is updating the kernel-specs.py file on the container's file system. And now all we have to do is just sit down, relax, and wait for a new notebook to be created.
But
nobody is getting applause for just an ugly diagram. So let's take a look a bit in the video. So here, in the left side, you can see our exploit, ASCII out as we love.
ASCII out, of course.
So in the right side, you can see an Ubuntu listener. So here, given a forwarding ID, we will try to enumerate the ports from 10,000 to 10,009, as I mentioned. Found out that 10,001 is the relevant port. Now we're trying to override, fetch, and then override kernel-specs.py file. Let's see if we can do it. Great. And now all we have to do is wait for the new notebook to be created. And let's see what happens when the user is logging in and creating a new notebook. A new notebook created, and we got the shell. Thank you. So this is the story of CosMiss. Now, some final thoughts about it. First of all, we want to say kudos for the team at MSRC for the quick patch. In less than 24 hours, they got our report, analyzed it, and fixed it in production. And to our opinion, it's crazy, and it is one of the biggest advantages on cloud. And second of all, and in my opinion, this is the biggest takeaway from CosMiss story, is that the cloud providers can't do everything by themselves. They have to rely on integrations. And these integrations might contain a lot of misconfigurations and a lot of vulnerability. And for you, as a security researcher, it is a great place to start your research in. So thank you very much.
Thank you,
we
guys.
hope you enjoyed. And have a great night.